Karissa Cordero, and I'm a first-year PhD student in the Earth and Environmental Science Department. Today I'm presenting preliminary cooling age estimates of hydrothermal explosions in Yellowstone National Park. Yellowstone National Park has some of the largest hydrothermal explosions in the world, reaching up to 2 kilometers in diameter. It's important that we understand these explosions and what causes them, so that we can understand the hazards they potentially pose for Yellowstone visitors. One of the primary questions of this research, in addition to finding the age of these explosions, is what causes these explosions. We believe these explosions are caused by a rapid reduction in pressure over the hydrothermal reservoir. Furthermore, we believe that it mimics the process of a glacier melting away, leading us to believe deglaciation could be a potential triggering mechanism for these explosions. We determine the age of these explosions through a geochronology technique called luminescence dating. Luminescence works by measuring the last time a grain of rock was exposed to sunlight or heat, which we call the luminescence signal. For the purpose of this study, we will focus solely on heat. When a grain is exposed to heat, no luminescent signal is able to grow. But when the rock cools down, the signal begins to grow, and we can sample the grain and determine when it turned from a hot system to a cool system. In terms of hydrothermal explosions, this would be the time that the explosion occurred and the grains were released into the air where they began to instantly cool down. Here, under field site, we have an outline of the Yellowstone Plateau that shows 2 hydrothermal craters. The primary sampling location was Pocket Basin Crater, which is shown in panel D. Below in sampling, we have zoomed up images of our sampling process. Panel A shows a photo of Pocket Basin as an overview, and panels B and C are 2 photos of our sample retrieval process. We take 2 different samples from every location. One is a sediment sample, and the other is a rock interior from an explosion-thrown boulder. We take 2 forms of samples because ideally, since they were formed from the same event, their ages should be the same. If the ages do not agree, it helps us determine if there's a more complicated geological history that we need to account for in the area. Under results, we have results for both the sediment samples and the rock interiors. The top 2 graphs shows the intensity of the luminescent signal over time. This helps us determine how resistant the signal is to sunlight and heat exposure. Below, we have 2 additional graphs called dose-response graphs. These shows how much incoming radiation the grains must have experienced to be giving off the measured luminescent signal from the lab. This helps us determine how long the grains are sitting there after they cool down. Combining the 2 graphs allows us to determine an age for these samples. The sediment sample shows an age of 16.4 plus or minus 4,000 years, and the rock core gave an age of 17.75 thousand years plus or minus 2.5. So both samples are within an age agreement. In addition to this, the ages fall within an event called the Pinedale deglaciation, which occurred between 16 and 20,000 years ago. This is when one of the last big glaciers was receding off the Yellowstone Plateau. This helps us establish that deglaciation is a probable cause of these explosions. This leads us to our future works. Here we have a picture of the Pocket Basin Crater in its entirety. We hope to go back to the field this summer at Yellowstone and take additional samples at Pocket Basin, and hopefully from a neighboring crater called Twin Buttes. In addition to the samples that we've already processed, we hope that we can get additional age agreements that offer an independent age check within the lab. The study is also a part of a larger geochronology study where we hope to apply different geochronometers and all come to a conclusion on the age of these explosions and hopefully find out what the cause behind them is, whether that's deglaciation or another event entirely. Thank you.